Choose the best block size for your cache among the choices given. Assume that integers and pointers are all 4 bytes each and that the scores array is 4-byte aligned. Let's take a quick look at the scores array. You should think of this as a large array in memory. It's got some number of students, that is its size, and so we can see that scores sub 0 might be located here in memory, and scores sub 1 could be located here, and so forth. Now, let's take a look at what the code is doing. In the code, we have an array that is going for 0 all the way up to num students. And what's happening is we just are sweeping through the array right here, reading in every single score, and we're continuously summing it right here into this variable. The question is asking us what would be the best block size for your cache, and the assumption is that what we're trying to do is to minimize the number of cache misses we experience. So let's begin by taking a look at answer A. Answer A says 1 byte in size. If the block size was actually only 1 byte, then in fact each cache entry would only store 1/4 of an integer in it. This would really not be in a very efficient granularity, especially since we're in this code in particular, we're focusing on 4 bytes at a time. So we're not going to accept answer A as a very good answer. If we did a 4-byte block size, that's answer B here, then we would say, all right, when we request in the first case here, scores sub 0, this would be a cache miss, and we would take this data here, and we would bring this into our cache. Okay, but we would exclusively bring scores sub 0 into the cache because the block size is only 4 bytes. So in the next iteration, when we're actually interested in scores sub 1, this would also be a cache miss. So on the one hand, we've brought in exactly what we needed, but on the other hand, we haven't really helped future loads from not missing in the cache. And what this is saying is that a block size of 4 bytes is not exactly leveraging the spatial locality that we expect our code to possess, and in fact, which we know that this code does possess. If instead the block size were 8 bytes, then when we brought in scores sub 0, we would actually also bring in scores sub 1. So this would be fetched into the cache line here, and because the block size is 8 bytes, then the data in scores sub 1 would actually go in the second half of the block. This has the nice effect of saying that in the first iteration, you would have a miss, but in the second iteration, you would have a hit. And if you think about this a little bit further, you can see that the longer the block size, the better the effect. So if our block size were actually 32 bytes, then we would have 1 miss followed by 7 hits. And that's in fact going to be the right answer, E. We want to prefetch as much as we possibly can so that we will amortize the expense of going to memory and have as many hits associated with a single miss as possible.